Our planet, spinning on its axis, defines time. One rotation represents one day. This single rotation divides into hours, minutes, and seconds. The rotating hands of a mechanical clock bring the rotating Earth into our home, and with an ingenious use of gears, divide this motion into hours, minutes, and seconds. Mechanical clocks use a sophisticated gear train to divide the day into hours, minutes, and seconds. The rate of rotation is controlled by an oscillating device, often a pendulum. In a folio clock, an oscillating arm controls the rate of rotation. To learn about clock gears, I constructed a folio clock from a kit. The force that drives this clock comes from a weight connected by a cord to a pulley. As the weight falls, it turns the pulley. The pulley is connected to a drive gear that transfers rotation to the rest of the gears in the clock mechanism. The oscillating folio arm controls the rate of rotation, releasing the escapement gear one tooth at a time. Without the escapement mechanism, the weight would drop to the floor, spinning the hands out of control. Small and large gears combine to change the rate of rotation. One turn of the large drive gear becomes 60 turns of the escapement gear. Another set of gears are used to ensure that the minute hand rotates at 12 times the rate of the hour hand. This folio clock movement, based on a centuries-old design, evolved into precision pendulum clocks and sophisticated chronometers. Let's take a look at some state-of-the-art 19th century clockmaking. Clocks designed to display time to a whole city. This clock tower is located above the City Hall in the city of Pembroke in the Ottawa Valley. Like most clock towers, it has 4 faces and a large bell to sound the hours. The clocks in these 19th century towers have some remarkable engineering and provide a wonderful opportunity to learn more about gears. This simple model shows the basic layout of a tower clock. The clock mechanism consists of a series of interconnected gears controlling rates and direction of rotation. The force driving the gears is provided by a suspended weight connected by a cable. As the weight descends, it rotates a shaft connected to the gears. The rate of rotation of the gears is controlled by the precise swing of a pendulum. Each swing allows a gear to turn by one tooth. This is accomplished with a special structure called an escapement. Another set of gears, bevel gears, rotate a long drive shaft that extends up to a hub at the center of the 4 clock faces. A set of bevel gears in the hub drive 4 rotating shafts that control the movement of the hands on each face of the clock. Let's take a look at the mechanism in this clock tower. The trip starts with a climb into the attic of City Hall. Our friend Serge has taken us up inside the clock tower of Pembroke City Hall. Lots of gears and a fascinating mechanism up here. This is the main clock mechanism. You can see the cables that are driving the mechanism. They are wound on drums and are connected to huge weights. There are 2 weights. One drives the clock, the other provides the force to strike the bell, We are looking up at the weights from below in this image. The huge pendulum swings under the mechanism, driving the escapement and creating the familiar tick of a pendulum-driven clock. The vertical shaft is driven by a bevel gear. This long rotating shaft extends to the very top of the tower, where the rotation is transferred to the hands on the clock faces. We climbed some steep wooden ladders to enter the very top of the tower. We are now inside the top of the tower. Daylight is shining through the translucent glass of these huge clock faces. This complex gear train is used to transfer rotation to the hands on the 4 clock faces. The rotating shaft from below creates the motion. Remember that gears can be used to change rates of rotation, and that the hour hand rotates once every 12 hours, while the minute hand rotates once every hour. This set of gears, called the motion works, create the proper 1:12 gear ratio and control the rotation of the hour and minute hands. Note the 2 counterweights. They balance the weight of the large hands. It is approaching 10 a.m., and this massive hammer and huge bell are about to announce the time. This action is all controlled by the clock mechanism, and again the force is provided by a weight attached to a cable. This clock is an elegant example of a practical and important use for gears. If you have a clock tower somewhere close to where you live, it will have a similar clock mechanism. Here in the Ottawa Valley, we also have clock towers in Arnprior, Renfrew, and Eganville. The Ottawa Valley is also home to the Canadian Clock Museum. It is open year-round and is located in Deep River. Worth a trip if you are visiting this part of Canada. For an introduction to gears and gear systems, view the video Gear Basics. This video can be accessed from our website, hylaroad.com. Follow the videos link.